All right, let's dive right in. Welcome to this explainer. Today, we're going to be looking at the human body a little differently, not just as biology, but as a highly advanced, incredibly sophisticated machine. And honestly, the very best part about this machine, it is completely optimizable. So today, we're opening up the Optimizer's playbook. We're going to explore exactly how we can measure, tune up, and completely upgrade our internal biology.
And look, we aren't just making educated guesses here. We're pulling these insights directly from the absolute cutting edge of biomedical research. The breakthroughs we're unpacking today come straight from the 49th annual meeting of the American Aging Association out in Madison, Wisconsin. These are the scientists literally at the forefront of understanding how we age and, way more importantly, how we can intervene and slow it down. So here is our roadmap for the day. First, measuring our true age. Second, the power of mitochondria. Third, clearing out senescent biological junk. Fourth, the diet-longevity connection. And finally, number 5, velocity-based training. We are literally journeying all the way from microscopic DNA right out to macroscopic gym performance. Let's get to it.
Chapter 1. Measuring our true age and finding the machine's real mileage.
So, chronological age, the literal number of candles on your birthday cake, well, that doesn't always match how old your cells actually are inside. To figure out the machine's actual mileage, scientists use what are called epigenetic clocks. These are biomarkers calculated from DNA methylation data, and they're used to predict your true biological age. Basically, think of DNA methylation as these tiny little chemical tags on your DNA that flip genes on or off as time goes by. By reading those tags, scientists can get a super accurate estimate of the actual wear and tear on your body. But historically, these clocks had a pretty annoying problem. They were noisy. Traditional clocks could deviate anywhere from 3 to 9 years between tests, which, let's be real, is pretty useless if you're trying to measure the impact of a subtle, day-to-day anti-aging habit. But researchers recently came up with a massive computational upgrade using something called principal components. By calculating these components from the DNA data, they basically strip out all that technical noise. The result? The deviation between tests drops down to a razor-thin 0 to 1.5 years. So now, tracking biological age over time is vastly more reliable. And speaking of reliable metrics, get a load of this number: 98. Researchers tracked a 98-fold increase in mitochondrial DNA deletion mutations between the ages of 20 and 80. A 98-fold increase! As our cells divide over the decades, the DNA inside our mitochondria just starts clonally accumulating these deletions, which completely messes up how the cells function. It's such a consistent, staggering spike that scientists are actually proposing this deletion frequency as a definitive new metric for biological age and physical decline.
Okay, so we've got the tools to measure the wear and tear. But that naturally begs the question, if we know they're aging, how do we actually power these cells more efficiently?
Chapter 2. The power of mitochondria. Time to upgrade the battery. We've all heard that mitochondria are the powerhouse of the cell, right? But they're also absolutely central players in the aging process itself. To get this, you have to understand something called proton motive force, or PMF. PMF is the electrochemical gradient across the mitochondrial membrane that literally drives cellular energy production. It is exactly like the charge on a battery. And here's the kicker. Just like that old smartphone you have sitting in a drawer, this cellular battery's capacity to hold a charge, the PMF, steadily drops as we age, and that decline is a major driver of biological aging. But here is where science starts sounding like sci-fi. Researchers have created this mind-blowing optogenetic tool called MTON. By exposing this tool to light, they can precisely, artificially boost that PMF. They are literally plugging the cellular battery back into the wall. When they tested this on C. elegans, a tiny microscopic worm, flashing that light completely reversed their age-related drop in PMF. The results were just phenomenal. It actually extended their lifespan and preserved their healthy mobility into old age. It proves that if we can directly target our cellular battery, we can profoundly reverse age-related dysfunction.
Chapter 3. Clearing senescent biological junk. Let's reverse the damage.
So, what exactly happens when parts of this biological machine get old and rusty, stop working, but just refuse to leave? Well, that is where senolytics come in. These are therapeutic agents designed to selectively hunt down and destroy senescent cells. These senescent cells are the biological junk hanging around your body. They're damaged, they've stopped dividing, but instead of dying off naturally, they just stick around in your tissues, spewing out toxic inflammation. Think of senolytics as the biological cleanup crew you call in to finally clear that junk out. And the clinical impact of this cleanup crew is nothing short of massive. Take a look at this stat, 1.5%. In a study looking at obese, older, non-human primates with naturally occurring type 2 diabetes, treating them with senolytics drove a 1.5% decrease in their A1C blood sugar levels. For anyone who tracks metabolic health, you know that dropping an A1C by 1.5% is an absolutely colossal, life-changing improvement for the entire systemic health of the body.
So how did they pull that off? The researchers gave these monkeys a senolytic combo known as desitinib plus quercetin, or D plus Q for short. After just one single dose, they measured a 24% reduction in the senescent cell burden right in the animal's fat tissue. Just that one sweep of the cleanup crew led to huge improvements in fasting glucose and triglycerides, and get this, it happened without any weight loss at all. But here's a crucial note for your personal playbook. The effects are reversible. Give it a few months, and that junk starts to accumulate again. It just goes to show that this machine requires ongoing, periodic maintenance.
Chapter 4. The Diet Longevity Connection. Choosing the right fuel.
Maintenance is huge, obviously, but so is the fuel we're putting in the tank every day. On one hand, we have standard high-fat and high-protein diets. On the other hand, we have carefully targeted protein and specifically isoleucine-restricted diets. Now, we've known for a long time that cutting overall calories is a gold standard for longevity. But let's be honest, walking around hungry all the time is pretty miserable, and it's super hard to stick to. So instead, scientists are now looking at restricting very specific macronutrients to try and cheat the system and get those exact same benefits. The data shows that high-fat diets actually crank up inflammation in the aging heart because they block something called mitophagy, which is basically your body's ability to sweep out dead mitochondria. But if you simply restrict dietary protein, it flips that switch back on, activating the clearance process and protecting the heart. Even crazier, researchers found that if you restrict just one single specific amino acid, isoleucine, it was enough to literally reverse diet-induced obesity in mice. It massively improved their body composition and glucose tolerance. So it's not always about just eating less overall, it's about exactly which microscopic building blocks you're withholding. All right, so we've learned how to track our epigenetic age, we've supercharged our mitochondria, cleared out the cellular junk, and dialed in the fuel. But how do we take all that internal optimization and translate it into optimizing our physical output in the real world?
Chapter 5. Velocity-Based Training. Time to rev the engine.
This is the moment where our internal biology meets our external physical performance. Enter velocity-based training, or VBT. This is a training method that uses tech to track the exact speed of your movement while you're lifting or exercising. If your optimized body is a high-performance engine, VBT is the RPM gauge sitting right on your dashboard. Instead of just guessing how hard you're working based on how heavy a bar feels on your back, VBT gives you precise, objective data on your absolute physical output speed.
And implementing VBT works on this great step-by-step hierarchy. Step 1, increase your training intent. Literally just trying to move the weight faster forces your body to recruit more muscle fiber. Step 2, auto-regulation. If your RPM gauge says your bar speed is dropping today, it means your central nervous system is fried. You back off the weight, boom, no more overtraining. Step 3, performance profiling. You can mathematically map out exactly what loads create peak power for your unique biology. And finally, step 4, full velocity-based periodization. This is where you plan entire training blocks around specific speed zones instead of arbitrary weight percentages. It is literally the ultimate data-driven optimization of human effort.
Well, we have covered an incredible amount of ground today. From stripping the noise out of epigenetic clocks and boosting that mitochondrial proton motive force, all the way to unleashing senolytics, restricting isoleucine, and perfectly dialing in our physical output with velocity-based training. The science of human optimization is just exploding right now, and it's giving us a level of control over how we age and perform that we've never had before. So I'll leave you with this one final thought. Armed with the Optimizer's Playbook, how will you manage your own biological machine today? Thanks so much for joining me on this explainer, and I will catch you in the next one.